Hey guys, welcome back. I want to share with you some concepts that we're going to be digging into this week about acceptance tests. Now, we've been working with test-driven development and writing what are called unit tests. Unit tests typically just test a specific function or a very tiny piece of functionality in a much larger system. Acceptance tests are written from the user's point of view. So they are, does the system behave the way the user expects it to when they interact with the system? So it doesn't necessarily mean it has to be user interface oriented, although it could often be that way. It's more about, at a higher level even than clicking and typing and so on. But when I present my credentials, I get authenticated. If I check out a book, then the book is marked, it shows as checked out, things like that. So that's exactly the example I want to do. I actually haven't written this code at all. I'll be honest with you. Actually, let's show you exactly what happened. I was Googling around trying to find some materials for you guys to read maybe, and let's see. It's potentially dangerous. And acceptance testing. There it is right there. Boom. Um, so acceptance test-driven development. I'll put this on Brightspace so you guys can read it. But it has an example here about given the book has not been checked out, any user who's registered on the system wants to check out a book, the book is marked, or when they check out a book, the book is marked as checked out. So I'm not going to take this exactly. I'm going to use a slightly different variation, but this little bit of syntax here, it's called a user story. Basically, it's a scenario. It says this is a one use case of the system, how a user would use the system, but it's written in a very particular syntax called Gherkin, and the testing framework that this was developed for is a framework called Cucumber. So Cucumber and Gherkin, kind of, get the joke. Gherkin is a kind of pickle. Cucumber is a thing you pickle to make a pickle. Anyway, so I cooked up a bit of Gherkin here, but it includes some data. So the way I am imagining this would work is you'd say the user wants to check out a book. How about, let's say, given a user wishes to check out a book from a library with these books. Okay, and then when they check out a book with a specific name, it should be marked as checked out. Okay, so that's the user story. Now, I haven't implemented this at all. I've just written the story. I do, and this, by the way, is called a feature file. So this is library.feature, so I'm going to describe various features of the software, and there could be different files for different, parts of the system. But the idea is that then there needs to be this. The idea of Cucumber is that this is a English description that any person, whether they're a computer programmer or not, could make sense of. They could even write these things, and then a programmer has to translate this into code. But the cool thing is, there's the software. It's called Jest Cucumber, which is a version of Cucumber implemented to use Jest. Let's put it that way. I just load a couple of functions from the Jest Cucumber package. I call load feature. That just loads up that in the features folder. There's the library feature that I just showed you. There it is right there. So this thing loads that library feature in, and then we pass that parsed feature into the define feature function, and we give it some tests. Now, so the point is, with the Jest Cucumber, is that you can simply load a couple of functions, define feature and load feature, from Jest Cucumber. You can use one of those guys to go out and load the feature file. Notice that here's the feature file we just talked. Oh, actually, it's right over here. There's the feature file. Close that. Don't need that. Okay. and it will actually parse the feature file. It'll see that you don't have any tests that match the scenario, and it will actually put in the terminal window, it will print out a template that you can just use as a starting point for your test. So I'm going to do it. I'm going to run the test. It says, well, golly, there's a feature file, has a scenario called check out a book, but I didn't find any testing code to test that. So here's a nice template you can use to get started. So I'm just going to grab that guy, pop it in here, and save it. And there I have, and I'm beginning with my test. Now, the thing is, notice it detected a table here. So I've got a table of data. And that table is just, it's literally an array of structures that hold this data. So it's the least thing it could possibly be. Actually, let's console log it out so you guys can see. Console log. Let's do JSON stringify table. And, yep, this is given. Okay. Now, then, of course, there's another table down here providing the detail of the specific book they take out. So again, I can console log that. Right when, there you go. It's GitHub Copilot is figuring out what I want to say. There you go. And then finally, it should be marked as checked out. So let's see what that looks like. We'll console log out that information. It's getting it from the feature file. So there's the given. It's a list of 2 objects with name and author. And then the other one is just a list of a single object, which is the name. And that's exactly what's in the feature file. So the Jest Cucumber is parsing this data in the feature file and passing it into me in a way that I can then use it to do some tests. And if my stakeholder wants to edit these and add some more use cases or change things, change the wording a little bit, that's okay. I mean, they can do that. They don't need to know JavaScript or TypeScript or anything else to be able to edit a feature file. So that's the beauty of the darn thing. So let's, now the thing is, I need to write these tests, but I don't actually have any code yet. There's nothing, my TypeScript file is empty. So rather than mix between the 2 files, I'm just going to go ahead and make some interfaces here. Let's make an iBook interface, which is the interface for a book. Will be name, string, author, string, and checked out. Right? And Boolean. And that will just be a record in our database or whatever that's going to keep track of the books in the database and whether they're checked out or not. And then I'll make a library interface, iLibrary, right? And what's it going to need? It's going to need some functions, right? So I need to be able to add a book. So add book, but let's not do it that way. GitHub Copilot, I want to actually do it this way. I'm going to pass in an object that's not an iBook because I don't need to pass in checked out. Let's do name, author, but not iBook. It needs to be partial. There you go. Okay. And then what else do I need? I need checkout book. That's a good guess. I'll take that. And then I also need is checked out. That's a good guess. And then, is that it? I guess probably that's it. Okay. Good. So let's, what's this complaining about? Oh. Okay, I'm so confused. Did I type it twice? I don't know. Okay. Somehow I ended up with it twice. Oh, that's GitHub Copilot trying to solve my problems for me. Okay. I gotta get rid of this one. Okay. There we go. I got two interfaces. I've got load feature, and I've got my template, which I put in. So the interface just tells me the functions that I'm going to define. I haven't defined them yet. They're not written, but they're going to be defined in library.ts once I get the test written. But remember how test-driven development works. I want to write the test first. So what have I got to do? First I've got to create a new library. So let's say before each, I'm going to let library equal new library. And oh, wait a minute, what is library? Library is a class that implements iLibrary. And right now I'm just going to leave it there. What does this say? Oh, it's saying it's missing these methods. Okay. So let's I'll just fill those in with empty methods. How's that sound? We'll do that. We'll do that. We'll do that. And we'll do turn false. Okay, those are empty implementations. So now at least it won't complain. I'll go back later and fill those in. So then I want to do const library colon iLibrary. I don't need to define it actually. But I better not make it a const. I better make it a let, because I'm going to assign it each iteration. Okay, so I create a library variable, a holder, and then before each test, I'm going to create a new library. So if I have multiple tests, each test will get a fresh library object to work with. Okay, so now I've got this table. Let's declare it as an array of any, because it's just a string object. So why can't I type any? There we go. And why cannot find name table? Okay. It's an argument. Oh, it doesn't like that. Let's do it this way. So what I want to do is iterate through the table. So I'm going to say table as any array for each row. Good. Not too bad. No, that's not what I want. For each row. Perfect. Actually, that's exactly what I was going to write. Library.addBook, name, author. Okay. And then that finishes the for each function. And that then finishes the given. Okay. So you see what's going on here. That should be the end. Oh, that's the end of the given. Okay. So what's going on here is given a user wishes to check out a book from a library with the following books in it. So then I get a table of books. So this given here is implementing the test for this part of the scenario. So it's setting up the scenario to have this context. Does that make sense? So the given is saying that's the situation, and then the given function is going to set up that situation. Okay, I'm going to fix these braces a little bit. Okay, that looks better. Now, so we've got the books in the library now. I've called the add book function, which right now it's actually just a empty implementation, but that's okay. That's what the test is going to need. Then when they check out a book with a specific name, so then I have to be able to get the name. So let's make that another. Let checked out book name. It's a string. Okay. And then that's what we're going to do here is to assign that. So we've got a table. We're going to say checked out book name equals table. Oh, perfect. Except it's capital N because it uses these. Oh, this should also be capital N and capital A because it's going to get these from the table here. Okay. Checked out name is table as any.name, and then what we're going to do is check to see, oh, I got the name. Now I got to check it out. Library checkout book, checked out book name. Notice, is checkout book in here? Yeah, checkout book takes a name and it checks it out. And then we're going to check and see, is it checked out? So expect library is checked out book name to be true. Perfect. And then I'm going to run that test. And of course, see what happens. It actually doesn't run at all. So why is it not running? Ah, I know. This should be, where's load feature? Here it is. It should be ... / features. Yeah, because features is a separate directory. Okay, let's try it again. Okay, it still failed. Feature file not found. ... / features. Library.feature. I'm in steps. ... / features. Library.feature. Why would it not be found? Hang on. Maybe it's not. Maybe the path is not relative to steps, but relative to the root. There we go. Okay. We expected it to be true, but it was false. And that, of course, is because the code's not written yet. So these are empty functions. So let's take the interface, both interfaces, plus the empty implementation. Having a hard time with this. Okay, copy that. Let's just get rid of this. Come over here and library.ts. Let's just paste this in there. Okay, I can get rid of all this stuff. I'll import that. iLibrary. iBook library from, it's just going to be ... / library. Okay. Why doesn't it like that? I got iBook, I got iLibrary, I got library. Oh, I know. Exploit. Perfect. Okay, it likes it now. So we just have to fill in these implementations. So let's do add book first. I've got a name and an author, so I'm going to say this dot books dot push name author checked out false. It should be okay. And why doesn't it like it? Oh. So we need to check to make sure that those are if name and author, then do that. Okay. So it's just, it needed me to make sure they were not undefined. Okay, check out book. So what do I have to do here? I need to first find the book. So we're going to say this dot books dot find, and we're going to pass in. So what happens is it returns the first element in the array where the predicate is true and undefined otherwise. So we're going to say const a book colon I book equals this book's find, and we're going to pass in a predicate I book or undefined. Pass in a search function, really. So it's going to be book, right? And it's going to return true if it's the book we want. So it's going to be book dot name equals name. Yep. And okay. Why doesn't it like that? Semicolon expected. Hang on. There we go. Okay. And then if a book, then we want to set a book dot checked out equals true. And we don't need that guy. Okay. That is no. Okay. Return book. We don't need return book. Is checked out. Do I need return book? Elements library, iLibrary. I don't need return book. Okay. I need add book, checkout book, and is checked out. That's all I have. Add book, checkout book, is checked out. Okay. And so is checked out. So what we're going to do is find the book again. So same plan here, and then return. So we could refactor this later and put that find in a different function that finds a book, and that will save some code. But instead of so let's do this. We're going to say result equals false, right? And let result equal false if a book result equals a book dot checked out and result. Okay. So notice we've got some duplicate code here to find a book. So that's a hint that maybe we could refactor that and make a separate function to find a book. and return the book that's found, and then we just have a checkout book which sets checked out to true, and is checked out, which returns whether the book is checked out or not. Okay, so there we go. Those are the now that we've written the code, will it pass? That's the question. It doesn't. So it says it's returned false. So why is that? Let's try to debug it. Very exciting. Okay, so that's it. All that dumb stuff, right? Curly braces instead of parentheses. What was I thinking? So anyway, and again, we might want to, let's just go ahead and refactor. I've done a red, I've done a green. Now let's do a refactor. I said we would do it. Let's add find book, give it a name. We're going to return and that way now we does that look right? Yep. Yep. And that way we can just stay here. A book, iBook, or undefined equals this dot find book. Name. Okay, and then we can do the same thing here. Right, and let's check the test. Well, it looks like it's running anyway. Does it still pass? Still passes. Okay. So find book is a nice new feature. We might be able to use that some other places. So let's go ahead and add that to the iLibrary interface. That way people will know that method is there. All right, that's all I have. So that took longer than I hoped, but that is kind of the way this game is played. You fiddle around, you realize, God, there's something not quite right. But notice that by writing tests and executing tests, it's a great way to make sure that you get something that works. And later when you can now build on top of that. You take it a little step at a time, make sure everything works every step along the way. All right, that's all I have for you for now. We'll talk to you guys next time.